Hi, in this video, I will be showing you problem number 25 of chapter 15, section 3. Use polar coordinates to find the volume of the given solid. Above the cone, z equal to square root of x square plus y square, and below the sphere, x square plus y square plus z square equal to 1. So in this problem, we are asked to use polar coordinates and we have to find the volume. Above the cone, so we are given one part of the cone because it is positive square root of x square plus y square. So it is upper part of the cone. And below the sphere, x square plus y square plus z square equal to 1. So let's look at the diagram here, a rough sketch of the diagram. So you have upper part of the cone and the lower part of the sphere. So they both meet. We have to find out where the two surfaces meet. So we have the upper part of the cone, whose equation is z equal to square root of x square plus y square, and the sphere here is x square plus y square plus z square equal to 1. So we'll see where the two graphs meet. Where do the two surfaces meet? So we have to set the two z's to be equal. So z equal to x square plus y square, which is the upper cone. So squaring this, and the sphere is x square plus y square plus z square equal to 1. By squaring the upper part of the cone, we get z square equal to x square plus y square. And you substitute that into the equation of the sphere. It's z square equal to x square plus y square, and substitute that into the second equation, which is x square plus y square plus z square equal to 1. So you get x square plus y square plus x square plus y square equal to 1. So that gives us 2 times x square plus y square equal to 1. So x square plus y square equal to 1/2. So this is the boundary of the disk. Actually, they intersect along a disk. So in fact, the two surfaces intersect along the disk, whose equation is x square plus y square less than or equal to 1/2. The boundary is the circle, x square plus y square equal to 1/2. So volume here we are asked to find out the volume above the cone, below the surface, below the sphere. So the top graph should be the part of the sphere and the bottom should be the part of the cone where the two graphs intersect. So x square plus y square less than or equal to 1/2. Top surface minus bottom surface. Of course, it's double integral over d. The domain is x square plus y square less than or equal to 1/2. Top surface minus bottom surface dA. So we are going to get to this equation. Volume is double integral over x square plus y square less than or equal to 1/2. The top is the sphere, square root of 1 minus x square minus y square, solving for z, minus the top part of the cone, which is square root of x square plus y square dx dy or dA. We are going to, because the domain over which we consider the volume is a disk, it's always a good idea to convert to polar coordinates. Anytime the domain is a disk, polar coordinates would be the best method to convert to. So it is theta varying from 0 to 2 pi, and that is the theta variation, and radius is 1 over radical 2. It varies from 0 to 1 over radical 2. Then use the fact that x square plus y square equal to r square. So we have x equal to r cosine theta, y is equal to r sine theta. In polar coordinates, x square plus y square equal to r square. So it is 1 minus r square minus r dr d theta. dA changes to r dr d theta in polar coordinates. So changing to polar coordinate, this is the integral we have to solve now. So note here, we are changing to the polar rectangle because both r and theta are finite limits. That makes our problem very easy, the computation very easy. So integral theta 0 to 2 pi d theta, r running from 0 to 1 over rad 2, square root of so if you distribute the r, we get r times square root of 1 minus r square. Then r times r, that will be r square dr d theta. So v is we actually removed the theta there. So we already wrote the theta. So it is just dr. So v equal to I1 times I2, product of two integrals. They are separable. One is purely a function of r, the other one is purely a function of theta. So it is I1 times I2. So we get I1 we are going to separately solve for, which is integral 0 to 2 pi d theta, which is just 2 pi. And then I2 is integral 0 through 1 over radical 2 r times square root of 1 minus r square dr. This involves two integrals. The first integral has to be done by u sub method. The integral of r square is r cube over 3. So that is very easy. So it is 1 over radical 2. So u sub method, 1 minus r square is u, negative 2r dr is du. So I2 will be equal to square root of u negative du over 2 minus r cube over 3. Everything evaluated between, r cube over 3 is evaluated between 1 over radical 2. If you change the u back to 1 minus r square, so it is 1 minus r square to the power 3 by 2 over 3 by 2 minus r cube over 3 between the limits 1 over radical 2. So as everything is in terms of r square, we can write them as one term. Also make note here, this is 2 and this is 3 over 2 below. So the 2 and 2 will get cancelled out, so you get negative 1/3. So you get negative 1/3 here, negative 1/3 over here too, which can be common factored out. So negative 1/3 times 1 minus 1/2 the whole power 3 by 2. By substituting the upper limit and substituting the lower limit, you get negative 1. Then you have minus here, but 1 over radical 2 the whole cube. But we already took the negative 1/3 out, so that makes it positive. So if you simplify this, we get, simplifying this, we get negative 1/3 times 1/2 of square to the power 3 by 2, which can be written as 1 over 2 radical 2 minus 1 plus 1 over 2 radical 2. Simplify that. That would be negative 1/3 2 times 1 over 2 radical 2 minus 1. So simplifying this further and taking the negative sign inside, we get root 2 minus 1 over root 2. Multiplying, dividing by root 2, rationalizing it, you get 1 over 6, 2 minus radical 2. This is the value of I2. Now we have the value of I2 and we have the value of I1. So I, which is the volume, can be rewritten as 2 pi times 1 over 6, 2 minus radical 2, which is pi over 3, 2 minus radical 2. So that is the volume under the sphere and above the cone. Hope this video helps.